The big shift here is that video models are finally starting to hold on to structure over time without collapsing under the compute cost. We're seeing long horizon generation, multi-shot camera control, and real-time restoration all move toward practical systems that can reason about memory, geometry, and latency at the same time. That matters because these aren't just prettier demos, they're the ingredients for usable world models, controllable production video tools, and on-device restoration that actually runs live. What changed this week is simple. The bottleneck is moving from can it work to can it stay consistent and can it ship. Let's explore the first paper, DEC-MEM towards minute-long consistent world generation with decoupled memory. DEC-MEM from the Kling team at Kuaishou Technology and the University of Hong Kong targets minute-long consistent world generation by replacing naive, dense, long context attention with a decoupled memory design. The core idea is to solve two failure modes in long horizon video rollout, attention dispersion, and linear cost growth using sparse global memory, which performs block-level top-K retrieval over history, and anchored local memory, which restricts attention to the most recent 8 frames to stabilize short-range transitions. Built on a 1B latent diffusion transformer and trained on the world MEM dataset, DEC-MEM uses multimodal rotary position embeddings for camera pose, patch location, and time, then fuses global and local branches with a learned gate. On the world MEM benchmark with 221 initial memory frames and 120 generated frames, it reaches 30.0785 PSNR, 0.0494 LPIPS, 9.8904 FID within the training window, and 25.2294 PSNR, 0.1006 LPIPS, 16.2667 FID under extrapolation, outperforming Oasis, MindWorld, and WorldMem. It also achieves 3.6496 frames per second, nearly 2 times faster than the strongest baseline. And in a 5.8, participant user study obtains 39.77% visual quality, 37.81% action controllability, and 42.12% spatial temporal consistency preference. Ablations show that top-K equals 80 is the best retrieval setting overall, while removing either sparse global memory or anchored local memory sharply degrades long-range consistency. Let's explore the second paper, OmniDirector General Multi-Shot Camera Cloning Without Cross-Paired Data. OmniDirector, developed by the Kuaishou Technology Kling team with Tsinghua University and Peking University collaborators, tackles general multi-shot camera cloning by replacing brittle camera parameter injection and scarce cross-paired data with a visual camera grid. Reference videos are decomposed into camera poses, rendered as motion in an empty 3D scene, and fed into a multimodal diffusion transformer as a spatial temporal conditioning stream. The method is trained on a million-scale camera grid video dataset built from 8M internet videos, then fine-tuned with a self-reconstruction objective on 30% of samples to force the model to learn geometry rather than appearance leakage. At inference, a hierarchical prompt expansion agent uses Qwen3 VL to generate intershot and intrashot camera descriptions and fuse them with a user prompt and reference image, while adaptive classifier free guidance separates camera structure from semantic refinement. On a 1094 sample evaluation set, OmniDirector outperforms CamCloneMaster, Cadence 2, 0, and LTX LoRa, reaching 2.64 degrees relative rotation error, 16.84 degrees relative translation error, 83.18% rotation precision, 72.74% translation precision, 96.52% transition, temporal precision, 83.79% transition, semantic precision, and only 0.51% frame leakage and 3.38% shot leakage. The paper's key novelty is that this camera grid representation also enables zero-shot camera understanding from raw RGB or canny edge inputs, showing that the model can generalize beyond explicitly paired camera data. Let's explore the third paper, Swift VR Real-Time One-Step Generative Video Restoration. Swift VR, from TeleAI at China Telecom and the University of Macau, is a streaming one-step generative video restoration framework built on the WAN 2 TI2V 5B backbone that targets live, high-resolution restoration under strict latency and memory limits. Its core novelty is mask-free, shifted window, self-attention, which encodes window locality, with deterministic indexing, so attention stays on standard dense SDPA kernels rather than mask-based or sparse fallbacks, and a lightweight restoration-aware autoencoder that cuts decoding overhead. Trained in 3 stages: latent flow matching, window attention distillation, and joint pixel space fine-tuning with adversarial supervision. SwiftVR reaches a 1.62 times throughput gain over its full attention teacher. On a single H10080G under causal streaming, it runs at 54.42 frames per second for 1,920 times 1,000 and 8031.32 frames per second for 2,560 times 1,440 and 13,84 fps for 3,804 12,130, while all compared diffusion-based baselines run out of memory at 4K. On a consumer RTX 5090, it achieves 26 frames per second at 1080p, which the paper presents as the first real-time 1080p generative video restoration on consumer hardware. Quantitatively, SwiftVR is the most efficient one-step method at 2,560 times 1,440, and the ReAE reduces the autoencoder bottleneck from 704.69M parameters in WAN 2 VAE to 40.95M, while preserving substantially better reconstruction than a tiny autoencoder. Across SPMCS, UDM10, UHQ40, and Video LQ, SwiftVR leads no reference perceptual metrics such as music, clip IQA, and mana QA in several settings, emphasizing perceptual realism over pure PSNR. That's a wrap on today's AI paper highlights. Thanks for watching.